Notorious DJ.
Hello everyone! In today's tutorial video, we will teach you how to solve for the dot and cross product of vectors using spreadsheet. To begin with, we have a given vectors of vectors A is equals to 3i plus 7j minus 6k, for vectors B is equals to negative 5i plus 4j plus 3k, and for vector C is equals to negative 2i plus 9j plus 9k. Based on the instructions, our program should be able to perform and find the following: the angles between vectors A and B, B and C, and A and C. Moreover, it should perform the orthogonal component, vector A to B and vice versa, B to C and vice versa, and A to C and vice versa. Lastly, it must find the cross product of vectors A and B and C, and A and C. So first, we should input all the values in the spreadsheet. So we have 3 for the x component, 7 for y component, and negative 6 for z component for the first vector, negative 5 for x, 4 for y, and 3 for z for the second vector. Take note that we will focus first for the vector A and B. And in order to find the magnitude of the first vector, we will use the formula square root of b4 squared plus c4 squared plus d4 squared. So for the first vector, we have a magnitude of 9.7. And we will also use the same formula for the second vector. So in finding its magnitude, we will use again the square root of b5 squared plus c5 squared plus d5 squared, which is a magnitude of 7.1. So we will now proceed in finding the dot product. So for the first vector and second vector and their components x, we will multiply b4 times b5, which is equals to negative 15. Then in the y component, c4 times c5 is equals to 28. And in the z component, d4 times d5 is equals to negative 18. And now, in finding the angle in between, we will use the formula a cosine close parenthesis b4 times b5 divided by the e4 times e5 plus c4 times c5 divided by e4 times e5 plus d4 times d5 divided by the e4 times e5 double cross parenthesis times 180 divided by pi is equals to 94.18. This is the angle in between. And for the orthogonal components of first vector to second vector, we will use the formula b7 plus c7 plus d7 divided by e5, which is equals to negative 0.71. For the second vector to first vector, its orthogonal components can be found using the formula b7 plus c7 plus d7 divided by d4, which is equals to negative 0.52. And now we will proceed to the cross product. So now we will type again the given for the following vectors. And now in finding the cross product for the x component, we will use the formula I4 times J5 minus J4 times I5, which is equals to 45. Then, for the y component, H4 times J5 minus J4 times H5 is equals to 21. And then for the Z component, its cross product is H4 times I5 minus I4 times H5. And in order to find its magnitude, we will use the formula square root of H7 raised to 2 plus I7 squared plus J7 squared, which is equals to 68.37. For its unit vector, we will just simply divide h7 over h8 for the x component. Next, for the unit vector of y component, I7 divided by h8. And then, for the unit vector of z component, we will just divide j7 divided by h8. So for each direction, we will use the formula a cosine h9 times 180 over pi, which is equals to 48 for 84. Next, for the y component, its direction is a cosine times I9 times 180 divided by pi, which is equals to 72.11. And lastly, for the z component, its direction will be defined by a cosine times j9 times 180 over pi, which is equals to 46.6. So we just need to repeat all the processes that we have done for the vectors BC and AC. So thank you for listening to our video tutorial.